In this lesson, we will cover loops. Loops are constructs that allow us to execute statements repetitively. The example that I give here is, suppose you have a variable n and you want to print a series of numbers starting from 1 all the way up till n. The easiest way to do that is to use a loop construct. The simplest loop construct is a while loop. It's available in Java, but it's certainly available in other languages. It is of the following form. So it starts with a new keyword, a new reserved word called while. Right? So again, reserved words are things you cannot use in other places in the program, like variable names. It's followed by a conditional expression. If this conditional expression is true, the body of the loop is executed. So in every iteration of the loop, the conditional expression is first evaluated. If it happens to be true, the statements in the subsequent block are executed one after another. If the conditional expression evaluates to false at some point, the loop is exited and goes to the bottom of the construct. Now, of course, just like conditionals if constructs, if the body only contains a single statement, the curly braces can be skipped and you can just use the statement in its place. So let's look at an example. Here we are doing exactly what I said earlier, where you have a variable n, which is initialized to 25, and we are printing numbers starting from 1 all the way to n. Here we're using a variable I as a counter. So let's try this out. I've already typed up the code right here. Again, two variables, I being used as a counter. While I is less than or equal to n, it prints the value of I. And then here we're printing a new line just for clarity. There. So another example would be that of calculating a factorial. Factorial, if you recall, is a mathematical operation. So 5 factorial is multiplying 5 times 4 times all the way down to 1. This is the code for calculating the factorial. Again, we're using a counter. Here we're setting the counter to be 5, which is the value that we want to calculate the factorial of. And we collect the factorial in another variable called factorial, which is initially set to 1. And in every iteration of the loop, we are decrementing n by 1, and we are multiplying the factorial variable with n, right? And when the loop will end when n is reaches 1. It will not be allowed to reach 0, right? And at the end, we print the factorial, right? So let's again try this out. I have typed in the code. We can run it. And here we get the result. Now, there are a couple of pitfalls that you should be aware of. First is that we have to be very careful about the condition that we use. For example, if instead of n greater than 0, you were confused and you use n greater than or equal to 0, you would get what's called an off by 1 condition. You're picking up an extra value. And you get a very different result. So let's try that out. If we were to put an equal sign here, you'll notice you will get a completely incorrect result. So we have to be very careful with our condition. The other thing we have to make sure that is during the looping process that variables are getting incremented appropriately. For example, if you were to forget this line of decrementing n, you would get what's called an infinite loop, meaning that the loop will never end. The program will appear to run forever, right? The infinite loop is a term you should get familiar with. Another term that you should get familiar with is an iteration. An iteration is a single go around of the loop. So loop goes through multiple iterations before it completes. Additionally, the same caution applies for using floating point variables for doing comparison, because floating point numbers are not held precisely in computing systems. They're approximate values, and may get very incorrect behavior. Another variant of the while loop is what's called a do-while loop, right? It is also available in several programming languages. This one goes through one iteration of the loop before it checks the condition. It is of the following form. You now again have yet another reserve word called do, which is followed by a block, and then while and a condition. This would first execute the body once, then the condition is checked. If it is true, it continues iterating over this loop till the condition is false. Do note that the construct must be followed by a semicolon. And again, if the block only contains a single statement, you can skip the curly braces. The question you may be asking is, why would you have this variant? And in some cases, it is useful to go through one iteration of the loop before checking the condition. Here's an example for you. Here we are prompting for a number, specifically a positive number. And we read the number, and if someone has entered a negative number, we prompt them again. So let's try this out. Here, again, I have typed in the code, so let's run it. So you'll notice it is first going and prompting before the condition is even checked, and if I enter a negative number, it will keep on asking. Right? It's only when I enter a positive number that the loop exits and prints the final statement. Now we get to our last looping construct, which is the for loop. Now you've noticed that in a lot of our loops, we've been using the notion of a counter to control the loop, right? So the typical pattern has been that we initialize a counter, we check the value of a counter for the end condition for the loop, and then we increment the counter or decrement the counter depending on the logic, right? Now the for loop allows us to specify this more succinctly, and the for loop has the following format. So again, we have a new reserve word called for, and it follows parentheses, and in the parentheses has three different clauses. The first one is the initialization clause, which corresponds to the initialization. So it can initialize the counter. The next one is the checks the end condition. So this is your Boolean condition for ending the loop. And the third clause increments the counter or decrements the counter, whatever the need may be. This is followed by a block which contains our statements. So to generalize this, here we are initializing our counters, or what we call control variables. Next, after the semicolon, we are checking the condition, the end condition. And lastly, we are updating the control variables. It's very important to update the control variables, otherwise you will get an infinite loop, right? Again, if the block only has a single statement, so you can skip the curly braces, right? You must use the parentheses, right? And it is best practice typically to also declare our control variables. So declare it right within the first clause. So it's all together in one place, right? So we can write our initial factorial example that we had initially implemented with a counter and a while loop more gracefully, more succinctly as with a for loop. So let's try that out. Here I've typed in the example already, and let's run it. There, we get the same exact result. Note that you are not limited to a single control variables. You can have multiple control variables, as I show here with I and j, and you can use them for the condition as well as increment or decrement them, right? So now you must be wondering that there are three different constructs we have introduced: while, do while, and the for loop. Which one should I use? It depends on your use case. If you have a situation where you have counters, then the for loop might be the most natural. The while loop is the most general one, and any for loop can be converted into an equivalent while loop. You can further have nested loops. You can have loops within loops. You can have an outer loop with a control variable which is I, and then the inner one which is with control variable j. Now you should be careful with the nesting of loops. As you'll see in this example, we have three different nested loops, one within another. And in this case, each one loops 10,000 times. And the example here, if the statement S1 it just takes a microsecond, 1/1,000,000th of a second, this loop will take 227 hours to complete. So you could have some serious performance problems if you're not careful with loops, right? Two other constructs that I'll talk about briefly is the break and the continue statements, right? You can decide to break out of the current loop and end it by using simply a break semicolon statement. You might have used break with switch statements earlier, right? Similarly, you have a continue statement. Continue semicolon will skip the current iteration and move to the next iteration. So it won't exit the loop. It will just skip the current iteration. So just like with complex constructs we had with conditionals, with the loops, we have pitfalls. Do note that for, do, and while are reserved words. You can't use them for variable names. Be careful with using floating point numbers in conditions, because floating point numbers are inherently imprecise in programming systems. You can get into infinite loops if you don't take care in updating your control variable such that the loop will end. And then also you can have the off by one error that we saw earlier and pick up an extra iteration or leave out an iteration if your condition is incorrect. So we just learned about loops. We went over three different constructs: while, the most general; do while, which does one iteration before it checks the condition; and then for loops, which are optimized for counters. Thank you.